Hello guys, good day. Today we're going to discuss how to analyze steel and concrete structures within 1 hour. Okay, we'll start. This is a completed project in project completed structural design analysis project in Marikina City. Proposed three-story residence with roof deck designed by yours truly, September 21, 2024. Part 1, Beam and Column Design. Here are the structural considerations. Number 1, I-beams should be used for all the main members, beams and columns. We will try W10 by 49 I-beams for all the members with corresponding detailed structural analysis. Number 3, verify if the W10 by 49 members are safe. As you can see, this is the front elevation for each level. This is the from the height of the from the NGL to ceiling level is 3 meters. Okay, then we will proceed to making idealized model. Then uh, graphical rapid analysis of structures program was used to analyze this structure. And this is the structure undergoing ultimate loads and anticipating worst case scenario with seismic analysis. Based from our earthquake analysis, the lateral forces are 70 kilonewton, 50 kilonewton, 35 kilonewton, 30 kilonewton, and 20 kilonewton. And the loadings for each each floor are 35 kilonewton per meter, 30 kilonewton per meter, 25 kilonewton per meter, and 20 kilonewton per meter. This is the deflected shape of the structure. The maximum actual force in the columns is 429 kilonewton. In the columns and the beams, the maximum actual force is 429 kilonewton. And then we will determine the cross-sectional area of the beam columns. 9,000. The cross-sectional area is 9,137 square millimeters. By making a program in Excel, these are our criteria for safety is actual area should be greater than required area for us to be safe. So our actual area is 9,137 square millimeters, and our required area is 2,860 square millimeters. So our actual area is greater than our required area. Our conclusion is the columns and beams are safe considering ultimate loads. Use W10 by 49 for all the main members, which is beams and columns. Now we're finished with the steel design. Now steel design. Now we will do next the reinforced concrete design, the footing tie beam, the pedestal, and the footing design. Footing design, this determination of the area of the footings. Uh, we will use 1.8 meters by 1.8 meter footings. The thickness of the footing should be 400 mm. And our footing reinforcement, uh, we, we, we will adopt 400 mm. The final dimensions of our footing should be 400 mm by 1,800 mm by 1,800 mm with 20 diameter rebar spaced equally both ways. All of these spreadsheets was here are made by yours truly. If you have questions, I am willing to answer it at the best of my capability. So this is the cross section of our ground beam or footing tie beams. This is our pedestal design. This is the pedestal design. So this is our structural details. Number one, we will use 25 thick base plate, steel columns all around fully welded to base plate. Use 6 3/4 inch diameter, 18-inch long anchor bolt with nuts and washers. The distance from the top of footing level to top of pedestal level is 2.1 meters. The cross section of the pedestal is 400 mm by 400 mm with 8 numbers, 20 mm diameter vertical bars with 2 sets 10 mm dia ties at 0.25 cc spacing. The distance from NGL level to bottom footing level is 2.5 meters. Depth of embedment. As of now, uh, I hope that you learned how to analyze analyze steel and concrete structures within 1 hour. If you have questions, feel free to message me. Once again, this is Engineer Lescano. Thank you very much for listening, and God bless.